We're back. Morning, everyone. We're back again, as I said we would. And morning, everyone. We're back again, as I said we would. And in today's experiment, under the subject principles of sound, we're going to demonstrate sound perception. What we have before us right now is ORTF stereo miking technique. This helps us emulate sound perception using the human head, how the ears pick up sound waves and translate. So as I speak right now, I'm emulating sound waves coming from like straight ahead of you. And we're going to see the pickup pattern as I move. Right now I've moved to my left, which is your right. As I'm speaking right now, we're recording. So we're going to see, using the analysis, how all that works out. In the middle here, and this is my far right side. So right now, positioning the mics like this, as you can see, these small diaphragm microphones are representing the human head, and the ends of the microphones are the ears. So as I speak from my right side, this torso, the nasal, and the head. We all differ in those areas, and thus how sound is perceived differently as well, because of the fact that our anatomy is different. So this is something close, not accurately. This will not accurately tell us the HRTS, but it's something that is close in terms of this will about this is the left side, the mid side, the far right side, and the back, using ORTF, stereo miking technique, to emulate how the ears work. Pick up sound. In talk about does it as well, think that about does it as So as I was saying, this won't give you accurate readings at HRTF, but this won't. So as I was saying, this won't give you accurate readings at HRTF, but something close. So what's happening here? As I move to the left side, my left side is somehow so into all of things that deal with this won't give you accurate readings at HRTF, left side and sound as I speak. IoT stands for binaural difference. That deals with the intensity of the sound, how loud is it, how soft. And the ITT deals with the interaural time difference. That deals with the time difference in time. So both these cues working interchangeably help us sound localization, help us localize sound, help us determine which direction the sound is coming from and how far. So as I move to my far left side and speaking, what is speaking of this? In this, imagine this is my head, and this is his left. As I speak from this side, the sound that will be direct sound will be hitting this one first. So as a result, in terms of it's going to localize the sound is coming from the left. And if I move here in the middle, the time of arrival from the source of sound to both microphones is very much similar. So with similar arrival time and IOD time, you're going to perceive the person as in front of you. To my far right, same explanation. Sound is going to be perceived as coming from this side, and the IOD will determine how far or close that person is. This whole setup helps us in sound perception. It helps us understand sound perception, how sound is perceived in each given setup. So, and the reason why, as I mentioned, this will be inaccurate is because if we look at this, it lacks certain features that are in the human anatomy, like the penis themselves, the torso, and the head. This space you are trying to emulate the gap that is created by the head, but it's not as accurate as it should be because almost very few frequencies have been attenuated. This will help us determine that.
These microphones that are picking sound with intensity as compared to because of the head-related transfer function. So I think just add your point here correctly. Since you could sound the mufiko kwa mic picking because it's behind.
So as I stand behind here, first of all, these are small diaphragm microphones, small diaphragm condenser microphones, and these function on a cardioid polar pattern. The cardioid polar pattern means the only part that is making sound is the front end, which means it's a front address. This is a front address. So
picking because it's behind.
So as I stand behind here, first of all, these are small diaphragm microphones, small diaphragm condenser microphones, the AKGs, and these function on a cardioid polar pattern. The cardioid polar pattern means the only part that is speaking sound is the front end, which means it's a front address. This is in front address. So with that being said, when I stand behind there is very little sound being picked because of the polar patterns itself. And this setup is similar to what happens in real life setup.
It's been sound it's been blocked by the shape of Excellent. So, since sound waveform it's been blocked by the shape of the accent. So, the low frequency, then the shape. So the fact that since sound waveform it's been blocked by the shape of the accent. So, the low frequency, then the high frequency. So the sound that pick up
with the shape, the polar pattern,
effect head related transfer effect high frequency. How the head shapes the color absorption and diffusion, especially for the high frequency.
So, as I was saying, this setup relating analyzing the pin and not. So, what happened with the shape of the pin and the head itself with regards to wavelength? So, what we need to understand when I say wavelength is the difference between low frequencies and high frequencies. So, high frequencies tend to have a shorter and low frequencies tend to have a longer. And because low frequencies have long wavelengths, it makes them difficult to locate. On the other hand, the higher frequencies are attenuated the closest try to see. As I was saying, this setup relating the human anatomy, the pin and not. So what happens with the pin, the shape of the pin and the head itself with regards to so what we need to understand when we say wavelength is the difference in low frequencies and high frequencies. So high frequencies tend to have a shorter wavelength and low frequencies tend to have longer. And because low frequencies have longer wavelengths, it makes them difficult to localize as their wavelengths surround even the perception and the direction. On the other hand, part of the lotus, especially extremely high frequencies, because they have the shortest wavelength. And once you have the problem, you don't need to high mid frequencies. So in this case, the microphones are simulating something similar. But this shape being considered in the eyes, in the ears, a lot of times from a lot of low power is why a lot of although I repeat, this is not an accurate way to determine HRTFs. This is just the closest option we've got to try to simulate how sound is perceived by the human. And as I said, the reason for that is because each individual's anatomy differs. The shape of the inner, the head, torso, mesocardium. Determine what each individual's tone color is going to be because of the different amount of reflection. due to the shows. So when it comes to sound perception, simulating the human head, this is a stereo writing technique that is and by the way, this is only one example of stereo writing techniques. There's more stereo writing techniques which help us manipulate the stereo image that we're trying to reproduce, like this. So, with that being said, thank you for tuning in. That will be Thank you for tuning in. Thank you for tuning in. What we have before us is ORTF stereo miking technique. This helps us emulate sound perception using the human head, how the ears pick up sound. And in today's experiment under the subject ORTF stereo miking technique. This helps us emulate sound perception using the human ear, how the ears pick up sound waves and transmit. So as I speak, I'm emulating the sound source coming from like straight ahead. And we're going to run through the audio and see the pickup pattern as I move. Right now I've moved to my left, which is your right. And as I'm speaking right now, we're recording. So we're going to see using the analysis how all that works out. In the middle here, and this is my forehead. As you can see, these small diaphragm microphones are representing the human head, and the ends of the microphones are the ears. So as I speak, how sound is standing behind. So these microphones are just demonstrate. And by the way, as far as HRTFs go, this is not the best way to go about resolving head-related transfer functions, because head-related transfer functions are catered for a specific individual depending on the shape of the ears, shape of the torso, the nasal, and the head. We all differ in those areas, and thus how sound is perceived differs as well because of the fact that our anatomy is different. So this is something close, not accurately. This will not accurately give us the readings of the HRTFs, but it's something that was close in terms of I think this will about do it. This is the left side, the mid side, and the far right side, and the back, using ORTF as a stereo miking technique to emulate how the ears would pick up sound. So as I was saying, this won't give you accurate readings as HRTF would, but something close. So what's happening here, as I move to the left side, my left side, and the mic's right side, my sound as I speak, first of all, we have what are known as binaural cues. There's ILD and ITD. ILD stands for interoral level difference. That deals with the intensity of the sound being received. How loud is it? How soft? And the ITD is the interoral time difference. That deals with the time difference in time arrival. So both these cues working interchangeably help us in sound localization, help us localize sound, help us determine which direction the sound is coming from and how far.
Yeah,